Imagine placing a cat inside a box. You close the lid and suddenly reality itself becomes uncertain. Is the cat alive or dead? Or is it somehow both at the same time? This is Schrödinger's cat, one of the most famous and bizarre thought experiments in quantum physics. But what does it really mean? And how does it connect to the mind-bending world of quantum mechanics? In this episode, we'll break it all down in a way that's easy to understand. No advanced physics degree required. Who was Schrödinger, and why did he put a cat in a box? Back in 1935, Austrian physicist Erwin Schrödinger was frustrated with the strange implications of quantum mechanics. To demonstrate just how weird things could get, he came up with a thought experiment involving a cat, a box, and quantum uncertainty. The goal? To show how the rules of quantum mechanics, when applied to everyday objects, can lead to completely absurd situations. The experiment: a cat, a poison, and a quantum particle. Here's how Schrödinger's experiment works. You place a cat inside a box. Inside the box, there's a radioactive atom that may or may not decay within a certain time. If the atom decays, it triggers a mechanism that releases poison, killing the cat. If the atom does not decay, the cat remains alive. However, according to quantum mechanics, the atom exists in a superposition. It is both decayed and not decayed at the same time. This means that until you open the box, the cat is both alive and dead simultaneously. But how is this possible? That's where quantum superposition and observation come in. The quantum connection, superposition, and the observer effect. In quantum mechanics, particles exist in multiple states at once until they are measured or observed. This is called superposition, the same concept we explored in episode 1. According to this idea, the radioactive atom inside the box doesn't pick a state, decayed or not decayed, until someone observes it. And since the cat's fate depends on the atom, that means the cat is also in a superposition of being both alive and dead until we open the box. The act of observation forces the universe to make a decision. What does it actually mean? Interpreting Schrödinger's cat. Schrödinger's cat isn't really about cats. It's about the weird way quantum mechanics works at a fundamental level. Scientists have debated for decades what this really means, and there are multiple interpretations. Copenhagen interpretation. The cat is both alive and dead until observed, at which point reality collapses into one state. Many worlds interpretation. When you open the box, the universe splits into two. One where the cat is alive and another where the cat is dead. Both outcomes exist in parallel universes. Quantum decoherence. In reality, superpositions don't last long for large objects like cats, so the paradox is just a thought experiment and doesn't actually happen in real life. But here's the kicker. Scientists still don't fully understand how quantum measurement works. Why does this matter? Real-world applications. Schrödinger's cat isn't just a strange thought experiment. It has real-world implications. Quantum computing. Qubits work similarly to Schrödinger's cat, existing in superpositions of 0 and 1 until measured. This makes quantum computers exponentially more powerful than classical ones. Quantum cryptography. Secure communication methods rely on quantum superposition and the observer effect. Future of physics. Understanding quantum measurement could revolutionize our knowledge of reality, time, and space itself. Schrödinger's cat is more than just a paradox. It's a gateway into the mysteries of quantum reality. But there's still so much more to explore. In our next episode, we'll tackle another mind-bending question. Do parallel universes actually exist? Don't miss it! Hit like, subscribe, and turn on the notification bell so you stay up to date with our series, Quantum Physics and the Universe. Comment below. If you were the cat in Schrödinger's experiment, what would you do?